Hey ladies and gentlemen, welcome to the video notes for Chapter 8, Section 4, which is entitled Trigonometric Ratios and Right Triangles. We're going to have a total of 6 videos for Section 8-4, 3 of them covering the first half of the lesson, 8-4A, and 3 of them covering the second half of the section, which we're entitling 8-4B. So what we're talking about here is we're introducing the idea of trigonometric ratios as they deal with right triangles. So there is some information that we already know about right triangles. First of all, they are triangles, which means they have 3 sides because every triangle has 3 sides. We've also, during our discussion of Pythagorean theorem, already discussed how the longest side of the triangle is known as the hypotenuse, and that it is always located opposite the right angle in the triangle. What we've not talked about yet, and what we're introducing today, is the idea that the other 2 sides, which are known as the opposite side and the adjacent side, also have names. The tricky part being that those names are entirely based on where they are located related to whichever acute angle we are dealing with in a given problem. So what we're going to do is we're going to go through 2 examples here in this first video, and then we'll do introduce the vocab behind sine, cosine, and tangent. Then we'll do one additional example in this video. Then there will be a second video that will cover examples 4 and 5, which are 2 additional examples of applying SOHCAHTOA. And then we'll have one final short video on how to use your calculator to evaluate sine, cosine, and tangent values. So in other words, we're looking at 3 videos for this set of notes. So down here in example 1, we have a right triangle PQR, where R is the right angle. When we are naming the sides of a triangle, we always locate the hypotenuse first. The way we do that is we'll locate the right angle, we go across the triangle, and that side, in this case PQ, is our hypotenuse. Once we've named the hypotenuse, we choose one of the acute angles, and that is a key. We're naming the triangles based on the acute angles. So we go in here and we find one of those 2 acute angles. In this case, we're going to do angle P is one of the 2 acute angles. I'm doing this in red. I'm going to name these 2 sides. So when we're looking at this, angle P, our 2 remaining side names are opposite and adjacent. So it should make sense to us that opposite would be the side that is located across the triangle from angle P. In other words, QR is the opposite side for angle P. Whereas the word adjacent, well, that means next to. So there are 2 sides next to angle P, but one of them is already named hypotenuse. So the other side, in this case PR, is our adjacent side for angle P. On the surface, that's not a very difficult idea. The difficulty comes in when we talk about, well, those are the names specifically for when we're dealing with angle P. If we are turning our attention from angle P to angle Q, now the opposite side is PR. And the adjacent side is now QR. So this idea that opposite and adjacent depend on which angle you're dealing with in a given problem is extremely important to trigonometry. It's something that if you cannot get it right every single time, you are not going to be very good at trigonometry. Okay? So let's do another example of this. Again, when we name the sides of the triangle, in this case we're going to do here example 2, we're going to name sides of triangle ABC. C is the right angle, so we start by locating the hypotenuse. We find the right angle, we go across the triangle. AB is our hypotenuse. We then choose one of the acute angles. We'll start with angle A, and we tell ourselves, okay, well, if I go across the triangle, BC is opposite. Again, that's for angle A. And AC is right next to angle A. That's my adjacent side. On the other hand, if I'm dealing with angle B instead of angle A, then when I go across the triangle to find the opposite side, I find AC. So AC would be the opposite side for angle B. Whereas BC is right next to angle B, so that would be my adjacent side. So that would be my adjacent side for angle B. Okay, and again, this is an extremely important piece of thing piece of an idea that's really, really important to right triangle trigonometry is that we can correctly identify A, B, and C every single time. Okay, we can identify the hypotenuse, the opposite, and the adjacent correctly every single time. Now, the reason that's important is because we have to know which sides we are dealing with in order to be able to accurately work with our trig ratios. So let's introduce those ideas, the ideas of sine, cosine, and tangent. These are new vocabulary words to us at this point. And it's basically, the idea is that for each acute angle in the right triangle, there are three possible trigonometric ratios. Those three ratios are the three new vocabulary words: sine, cosine, and tangent. And each one of those ratios, being ratios, they are going to be comparing two of the three side lengths of the triangle. Now, in reality, there are actually 6 trig functions, but we're only working with 3 of them at the geometry level. These 3 are called the basic trig functions, okay, the basic trig ratios. Whereas when you get into pre-calculus and trigonometry, you'll learn about the other 3 ratios, which are known as the reciprocal trig ratios. So that's not important right now. So I have 3 new vocab words here, starting with the idea of the sine, or S-I-N-E. That is going to be abbreviated with S-I-N. And that's the button you'll locate on your calculator. Every scientific calculator has a sine button. The sine of an angle is the ratio of the length of the opposite side to the length of the hypotenuse. Now, notationally, what that looks like is sine of an unknown angle. This Greek letter theta is used to represent an unknown angle. It's just a variable. So if theta bothers you, replace it with an x. It doesn't make any difference. It's just a variable. The sine of the angle is equal to the ratio of opposite to hypotenuse. Our second new vocabulary word is cosine. C-O-S-I-N-E, which is abbreviated C-O-S, and is the second of the 3 trig buttons on every scientific calculator. It is the angle, or the cosine of the angle is the ratio of the length of the adjacent side to the hypotenuse. Similar notation has us writing out that the cosine of a given angle is equal to adjacent over hypotenuse. Finally, our third and final new vocabulary word is the idea of tangent. Now, this is only one usage of the word tangent in geometry alone. The word tangent has several different meanings in mathematics, but in this case, the trig ratio version of tangent is the ratio comparing the length of the opposite side to the length of the adjacent side. Tangent is abbreviated T-A-N, and that is the third trig button that exists on every scientific calculator. Again, notationally speaking, we would say tangent of the angle, whatever angle we're working with, is equal to opposite over adjacent. Now, when we learn these sort of things in mathematics, in science, in geography, and history, it's very common for there to be some sort of mnemonic device to help you remember this information. And in mathematics, it's a very common mnemonic we use called SOHCAHTOA. Now, I don't like to write SOHCAHTOA like that. I like to write it as SOHCAHTOA. And here's why. We need to memorize this because it helps us remember what sine, cosine, and tangent are. Watch here as I highlight. Sine is opposite over hypotenuse, which is SO. Cosine is adjacent over hypotenuse, ka. And tangent is opposite over adjacent, TOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. That will help us remember sine, cosine, and tangent's definitions, which will be extremely useful. So it is something that every high school geometry student, every geometry student period at any level, should memorize. Okay, we're going to do one more example and then we'll end this first video here. We are going to do one example of writing out the sine, cosine, and tangent of each acute angle in a triangle. So here we have triangle ABC. Our directions read write out the sine, cosine, and tangent of each acute angle in this triangle as both a fraction and a decimal rounded to the nearest hundredth. So what we do is, first of all, notice that notationally there are two different sets of information here. We're asked to provide the sine of A, the cosine of A, and the tangent of A. That's referring to angle A. Down at the bottom, sine of B, cosine of B, and tangent of B means we're turning our attention to angle B. So we're going to write out the three trig functions, the three trig values for angle A, and then the three trig values for angle B. This is going to involve the use of sine, cosine, and tangent. So again, SOHCAHTOA is going to come into play here. My suggestion as a math teacher is that you always write that down. You'll have it memorized in no time if you write it out on every problem. So what we do is we go in and we start by identifying the side lengths like we did in examples 1 and 2. The first thing we do is we identify the hypotenuse. C is the right angle. If we go across the triangle, we locate AB, or 5, which is the length of our hypotenuse. I've labeled that in purple because I'm going to do half the problem in red, half the problem in blue. Red plus blue is purple. And the hypotenuse is the hypotenuse, period. It never changes. So 5 is the hypotenuse for both angle A and angle B. So we're starting this problem looking at angle A. If we look at angle A, we go across the triangle, 3 is going to be our opposite side for angle A, and 4 is going to be our adjacent side for angle A, as discussed in examples 1 and 2. So what we do is we set up these proportions. So sine of A, sine is opposite over hypotenuse. So we're going to use the red opposite, and we're going to put that over the hypotenuse, which is the same no matter what angle we're looking at. So we'll leave that in purple. That would be 3 for the opposite and 5 for the hypotenuse. 3 over 5 is the fraction that we're asked to provide here. It is the sine of angle A. It cannot be reduced, therefore it is the fractional answer. To turn that into a decimal, we simply take our calculator and do 3 divided by 5 to get the decimal 0.6, which is an exact answer, so we don't need to worry about rounding. We're going to do the same sort of thing for both cosine and tangent. For cosine, we are doing adjacent over hypotenuse. Again, I'm color coding so that we can realize that hypotenuse is the same all the time. So the red label on adjacent would give us 4. Hypotenuse is 5. So the cosine of angle A is 4 over 5, which is our fractional answer. I guess I should have circled this decimal as well. Again, we put that into the calculator and we divide to get the decimal answer of 0.8. Finally, for tangent, tangent is opposite over adjacent. Again, that's coming from up here at SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So that would be 3 over 4, which again does not reduce, so that is our fractional answer, and that is equal to 0.75, which is the exact decimal. We don't need to round. So that's it for A. Now what happens here, what's tricky about this is when we turn our attention to angle B, we have to reconsider our labels. The hypotenuse is still the hypotenuse. That has not changed. But if we're working with angle B, then 4 is now our opposite side. And 3 is now our adjacent side. So when we go to do these trig ratios, our answers are going to be a little bit different, although related. So sine is opposite over hypotenuse. Oop, I shouldn't be doing that in red, should I? That should be in blue. Sine is opposite, which is now the blue label, over hypotenuse, which would be 4 is the opposite for angle B, and the hypotenuse is still 5. Well, we've already done 4 over 5 once. We already know what that decimal equals. That is equal to 0.8. Cosine, again from up here in the definition, cosine is adjacent over hypotenuse. Which would be, in this case, 3 over 5. Again, we've already done that. That's one of our answers. That's the fractional answer for cosine of B. That is equal to 0.6. Finally, for tangent, we are doing opposite over adjacent with the blue labels, which would be 4 over 3. And this is the first time we've had a decimal that we had to round off. 4 divided by 3 is 1.3 repeating. So when we round that off to the nearest hundredth, we look at the thousandth digit, which is a 3. Since that number is less than 5, we would round down or leave the previous digit alone, meaning our approximate decimal answer will be 1.33. And that is how we're going to approach these problems. Our next video will have 2 additional examples of this problem type. One of similar difficulty to the one you're looking at now, and one with numbers that are significantly less friendly. All 3 will contain radical expressions. In both cases, as long as you have a calculator, the work is not really any harder. Okay? So, that does it for the first of our 3 video session here in 8.4a. Thank you very much for your time and attention.